Hello, I'm Malisha from group number 23. As you seen on the screen, our topic is interpreters. First, I pay my attention towards what is an interpreter. According to the definition, an interpreter is a program that simulates a computer that understands high-level language. Rather than translating the source program into a machine language equivalent, the interpreter analyzes and executes the source code instruction by instruction as necessary. Here is the ideal concept of an interpreter. The main purpose of an interpreter is converting source code or high-level languages into machine codes or low-level languages. High-level languages are languages that can only understand by humans. These languages cannot understand by computers. Therefore, it is necessary to convert them into machine codes that can only understand by computers. For this process, interpreters are used. Some popular interpreters used on nowadays are Python, Ruby, Perl, and PHP.
This part includes the strategies of interpreters. It can work in three ways: execute the source code directly and produce the output, translate the source code in some intermediate code and then execute this code, and using an internal compiler to produce a precompiled code, then execute this precompiled code. Bytecode interpreters, threaded code interpreters, abstract syntax tree interpreters, and self-interpreters are some varieties of interpreters. Under this part, we discuss about the concept of interpreters. As mentioned above, all high-level languages should be converted into machine codes for computer understanding. With the time, various types of technologies were introduced, like compilers and assemblers. This type technologies translate entire program into machine languages by one go and consume more space as it stores object code in memory for execution. Consume more time as it produces intermediate machine code, and debugging is more hard as error messages are generated only after scanning complete code, and also some languages are machine dependent. Because of these properties, the effectiveness and fastness of the process was reduced. As a result of many experiments, interpreter was introduced based on the technology of compilers and assemblers. The first interpreter was introduced in 1952, and the first interpreted high language was Lisp. The special properties of interpreters are: convert the entire instruction line by line, errors are generated after scanning line by line, and do not generate intermediate object code.
In this topic, we discuss about the differences between previously introduced assemblers, compilers, and interpreters. According to the chart, assembler converts low-level languages into machine codes, while compilers and interpreters convert high-level languages into machine code. Assemblers translate the program before running, and compilers translate instructions line by line. Another difference between assemblers, compilers, and interpreters is the way that error display. In assemblers, errors are displayed before program is running. In compilers, errors are generated after scanning complete code, but in interpreters, errors are generated after scanning line by line. In assemblers and interpreters, required memory is less, while required memory is high in compilers. Assemblers and compilers generate intermediate object code, but interpreters do not generate so. Assemblers consume more time than compilers, and compilers consume less execution time than interpreters, but interpreters use more time for execution than compilers. Interpreters are the most interactive technology. Some common examples for assembler are GAS, GNU. Compilers are C, C#, Java, and C++. Now we are discussing about the development in interpreters. With the improvement in technological field, interpreters also improved in technology. Transtrpreter is one example. It is a transputer interpreter and it is small, portable and efficient. As well as it has a extensible runtime. It can be used in handheld computers, mobile phones also. As well as there are some specializing interpreters which use offline partial deduction. It can be used for small functional programming languages and it can be known as a logic programming self-interpreter. This brings me to the end of our presentation. In summary, we discussed about the interpreters under the few topics as the introduction, concept of interpreters, comparison with similar approaches and recent advancements of interpreters. Thank you.